Welcome to your Algebra 2 Lesson 9.4. Our objective for today is to graph and write equations of ellipses. So what is an ellipse? An ellipse is a set of all points P in a plane, so we're talking about a two-dimensional figure, that the sum, so we'll be adding two things together, of the distances between P, any point on the ellipse, and two fixed points called the foci is a constant. Now, foci is the plural of focus. So we don't have just one focus, we've got two of them, and so we call them foci. In this particular ellipse, there's a left focus and a right focus. So if we take any point on this set of points P, okay, let's pick this point right here. If we do the distance from that point, this little point right here, to the left focus, and we add that to the distance from that point to the right focus, we're going to get a fixed value. And the thing is that fixed value is true no matter which point we pick. When we do the sum of the distances from that point to each focus, it's going to be constant. Okay, so the bits and pieces. The line through the foci, each focus, intersects the ellipse at two vertices. Vertices is the plural for vertex. So for an ellipse, you have two vertices. So it goes vertex, then focus, then center, then focus, and then vertex. The distance from the center to a vertex is called A. Okay, so that's A units. The distance from the center to a focus is C. Okay. Now, the midpoint of this major axis that goes from vertex to vertex is the center, okay? And so perpendicular to that we have what we call the minor axis. It goes through the center. Where it intersects the ellipse is at what is called a covertex, and together they're called covertices, and they are B units away from the center. So the vertex is A, a focus is C, and a covertex is B, units away from the center. Now, in this chapter, for our purposes, ellipses will either have a horizontal or a vertical major axis. This is a case where the major axis is horizontal. So here's another picture of it. Here's a horizontal ellipse. We know that this is the major axis because it's got the vertices and the foci on it. The minor axis has only the covertices. Now for ellipses, it's true the major axis is always longer than the minor axis. Okay? A is always bigger than B. Now, we can reorient a vertex to be a vertical ellipse, an ellipse to be vertical, and we would reorient each vertex. This time we have an upper vertex and a lower vertex. The source for this particular picture used F1 and F2 for the upper focus and the lower focus, and that's fine, but here's a focus and here's a focus, and they all line up with the center. Again, quickly I can say, oh, here's my major axis, because the major axis always goes through vertex, focus, center, focus, vertex. Minor axis always goes from covertex to covertex. Now, on your graphs of your ellipses, I'm going to want a V listed for each vertex, F listed for each focus, and CV for each covertex. Out to the side, you'll actually have the coordinates, so I don't really need you to label the coordinates. I want you to label the role that they play. Okay, so like we said, you can have a horizontal major axis, which gives you a horizontal ellipse, or you can have a vertical major axis, which gives you a vertical ellipse. Because A is greater than B is greater than 0, A squared is always going to be bigger than B squared. So if you look, the standard form for our horizontal ellipse is x squared over A squared plus y squared over B squared equals 1. That means x squared is going to have the larger denominator. For our vertical equation in standard form, we have x squared over b squared plus y squared over a squared equals 1. A squared is always bigger than b squared, so y would have the larger denominator. Okay, if we have a horizontal major axis, that means the vertices are going to line up horizontally relative to the origin, and so they're going to be at plus or minus a, 0, and our covertices will be at 0 plus or minus b because they will line up vertically. Okay, major axis is horizontal, minor axis is vertical. In our other situation where our major axis is vertical, the vertices will line up vertically to the center, and so they'll be at 0 plus or minus a, and the co-vertices will be at plus or minus b, 0. All right, each vertex is a units away from the center, and so the major axis, which goes from vertex to vertex, is going to have a length of 2a. Likewise, the minor axis goes from co-vertex to co-vertex, and so it's going to cover a distance of 2b. The foci of the ellipse lie on the major axis. They lie on the same axis as the vertices, and they are a distance of c units from the center, where c squared equals a squared minus b squared. Now, if you're worried that you're not going to be able to memorize all this, don't, because you are going to be given these formulas on a formula sheet. I just want you to be able to use them. Okay. We're going to graph the equation 4x squared plus 25y squared equals 100. We're going to identify the vertices, co-vertices, and foci of the ellipse out to the side. So when we go to graph, we're just going to label the critical points based on the role they play because we have their coordinates over to the side. All right, so recopy the original problem, the original equation. So 4x squared plus 25y squared equals 100. And then let's put it in standard form. All right, well, standard form has 1 on the right-hand side. So the way we get 1 on the right-hand side is we divide both sides by whatever's there. So we're going to divide both sides by 100, which means we're going to need to reduce 4x squared over 100 plus 25y squared over 100, and then 100 over 100. 4x squared over 100, the 4 will cancel with a factor of 4 and 100, and we'll be left with x squared over 25. 25 will cancel with a factor of 25 and 100 for the y squared term, and we'll leave us with y squared over 4 equals 100 divided by 100 is 1. It's the whole reason we did this. Now, the next thing you need to do is decide, well, what's a squared and what's b squared? Is this a horizontal or is it a vertical ellipse? A squared is always bigger than b squared, so 25 is a squared, which means a is the square root of 25, so a is 5. B squared is always smaller, so for an ellipse, so b equals the square root of 4, so 2. Since we have the larger value under x squared, that means we have a horizontal ellipse. So identify the vertices, co-vertices, and foci. Note that a squared is 25 and b squared is 4, so a is 5 and b is 2. The denominator of the x squared term is greater than that of the y squared term, so the major axis is horizontal. Okay, so that means that the vertices are going to be at plus or minus a, 0, so at plus or minus 5, 0. So if you want to go ahead and put that on your graph, you can. We're going to look at the graph in just a second. The co-vertices are at 0 plus or minus b, so 0 plus or minus 2. And we need to find the foci, which means we need to determine c. C squared equals a squared minus b squared, so 5 squared minus 2 squared is 21. So c is square root of 21. If you have your calculator with you, you can put square root of 21 in to get that it's about 4.6. If you don't, what you need to do is you need to think of the square roots of perfect squares. Square root of 16 is 4, square root of 25 is 5. Because 21 falls in between 16 and 25, its square root has to fall in between 4 and 5. And so you can just estimate and put it each focus up between 4 and 5 points away from the 0 point. Okay, 4 and 5 units away from the origin. All right, now the authors of the book and people who gave me the examples to work with here, they've labeled the actual coordinates of the different bits and pieces. You have that out to the side. So what I want to know is that you know what role each of these points play. So here at negative square root of 21, 0 and square root of 21, 0, I want f and f because those are your two foci. At negative 5, 0 and 5, 0, I want a v and another v because those are your two vertices. At 0, negative 2 and 0, 2, I want CV because those are your co-vertices. So let's check. Let's see, we said that each vertex is always 5 units away from the center. A is 5. Here's a vertex, it's 5 units away. Here's a vertex, it's 5 units away. Co-vertices are supposed to be B units away. Yep, they're both 2 units away. foci should be C units away, and they are, so we should be good to go. All right. So our next problem, if you'll notice, I have some graph paper there, but it's not going to tell us to graph. That's just so that we can look and see how things line up. If you want to sketch in the whole ellipse, that's fine, but you need to see at least how the bits and pieces line up compared to the center. Write an equation of the ellipse that has a vertex at 0, 4, a co-vertex at -3, 0, and center at 0, 0. Okay, so they're going to describe things here, and then I'll show you how I would put the information given to us on a graph, and just from that graph get what A equals and what B equals, and also the orientation of the ellipse. Sketch the ellipse, or at least put what they give you on the graph, as a check for your final equation. By symmetry, the ellipse must also have a vertex at 0, -4. If it's got one at 0, +4, it has to get one at 0, -4. And a co-vertex at, well, it's got one at -3, 0, so it has to have one at +3, 0. Because the vertex is on the y-axis, right, 0, 4, that's on your y-axis, and the co-vertex is on the x-axis, the major axis is vertical with A equal 4, and the minor axis is horizontal with B equals 3. Now, I like to put this stuff on the graph so I can see it. So my center's at the origin. The vertex they gave us was 0, 4. So I can look at that. I can put that on there, and that immediately lets me know, oh, this is a vertical ellipse. A, this distance from 0, 0 to my vertex, is going to be squared, and that's going to be my denominator of y squared. Okay, so from 0, 0 to 0, 4 is 4 units. So A is 4, and A squared is 4 squared, and that goes under my y squared because this is a vertical ellipse. The co-vertex they gave me was -3, 0, and I go, okay, so that means B is 3, and so 3 squared will go under x squared, and then equals 1. So x squared over 9 plus y squared over 16 equals 1. So really all you need to do is know where the vertex is and where the co-vertex is. If you want to go ahead and get the other co-vertex from symmetry and the vertex from symmetry and sketch in the ellipse, that's fine. But this is our answer. X squared over 9 plus y squared over 16 equals 1. All right, let's look at this next one. We're going to write an equation of the ellipse that has a vertex at -8, 0, and a focus at 4, 0, and a center at 0, 0. So just looking at this, I can tell that A is 8 because the vertex is 8 units away from the origin, and I can tell C is 4 because the focus is 4 units away from the center. Now, when I plot these on my little graph paper, they better line up on the same line because a vertex and a focus both go on your major axis. So make a sketch of the ellipse, or at least the bits and pieces that they gave you. Because the given vertex and focus lie on the x-axis, right? So we were given -8, 0, and 4, 0. They line up together. They're not on the same side of the center. Here's -8, 0, and here's 4, 0. You can use symmetry to fill in the other focus and the other vertexes if you want, but that's really all we need because we know we have a horizontal ellipse. That means that A squared is going to go under x squared. So we know A is 8, so we can go ahead and do x squared over 64 plus y squared over, and just leave it blank for now, equals 1. The other piece of information we have is the distance from the center to the focus, which is 4. That is C. We need B. So to find B, we're going to use the relationship between C squared, A squared, and B squared. So we're going to do C squared equals A squared minus B squared. And so we're going to have 4 squared equals 8 squared minus B squared. So if you solve, if we add B squared over to the left and then subtract 4 squared over to the right, we get B squared equals 8 squared minus 4 squared, so 64 minus 16, which is 48. We really don't care what B is. We really care what B squared is because that's going to be our denominator of y squared. And so we just plug in what we know, x squared over 64, because we knew 8 was equal to A, and 8 squared was going to be the denominator of x squared because the vertex and the focus line up horizontally relative to the center, plus y squared over b squared, and we just calculated that b squared is 48, and that equals 1. And that is it. Please try the problems to try on your own. If you cannot do them, then either review the video, go to the PAL Center for Tutoring, or come in and get help from me, because you really need to have those problems to try on your own done so that you are prepared to check them when you first come to class and then ready to do the rounds. Okay, that's all I have for you today. I will see you in class soon. Thanks again to McDougall, Littell, and Larson, Holt McDougall, all the people who helped make this possible. Bye. Have a good day.